So friends, today our topic of discussion is implementation of a 2D array which can be done by two methods, that is row measure representation and column measure representation. So our first discourse is the row measure representation, which gives priority to the rows and next priority to the columns. And in the column measure representation, it is just the reverse, it is the vice versa of the row measure representation, that is column is given the higher priority and row is given the next priority. So in the first instance, we are going to discuss about the row measure representation, how it is done, how the sums pertaining to that type of concept is done. I will show you an example by which the different sums on the row measure representation can be calculated if you supply the base address and some values of different data, we can find out some missing data. So first of all, the concept will be given to you by means of a logical representation of a two-dimensional array, and I will draw a two-dimensional array on the board in order to show you the logical implementation of the two-dimensional array and its physical implementation of the two-dimensional array in the computer memory. So in the row measure representation, the first topic of discussion is row measure representation, where row is given the higher priority than the column. Row measure representation. So row measure representation is given the in which the row is given the priority. So here, if we just examine an array, a simple concept of an array, of a two-dimensional array containing three columns and 3 rows, that is, these are the rows and these are the columns. So if you consider this to be a two-dimensional array in the logical way of representation, it is not necessarily stored in the memory of the computer in this method, because in the computer memory it is stored as a one-dimensional array, not as a two-dimensional array as is looking in this figure. So it is just for the logical representation. In order to make you understand, in order to make things simple, we will visualize the two-dimensional array as this sort of structure having rows and columns, a tabular structure containing rows and columns. So here we are dealing with an array. Say the name of the array is A and the row dimension is 3 and the column dimension is also 3. So A33 is the array to be declared and whose logical representation is given here. So the index will be starting from 0, 1, 2 and here also 0, 1, 2. So in the row dimensional representation, in the row measure representation, this is the index of this cell 0, 0. This cell has an index of 0, 1. This cell has indices of 0, 2. This cell has an index of 1, 0. This has 1, 1. This has 1, 2. This has 2, 0, 2, 1, 2, 2. So these are the different row and column indices in the different cells of these logical representation. So if we give the priority to the row, in case of row measure representation, we give the priority to the row. So if we give the priority to the row, so the numbering, so the memory representation is done, in the memory allocation is done by row. That is, if we store these elements in a one-dimensional array in the memory of the computer, that is in the physical memory, not in the logical sense, so there only will be 9 elements. So there are 9 elements, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So it will be stored in a linear representation, not in this tabular form. And what will be given priority? Row will be given priority. So that's why our numbering will be like this. Suppose this will be 0, 0. This will be taken to be the second element of this one-dimensional representation. This will be 0, 1. This will be 0, 2. This will be 1, 0, because it will go like this. It will traverse left to right, then come again to this row, left to right, then come again to this row, left to right, like this. So we are moving top down, left to right. So it is nothing but top down. We are moving top down, left to right in a zigzag way. So this is the row major representation, that is 0 0 0 1 0 2 1 0 1 1 1 2 followed by 2 0 2 1 and 2 2. So if any elements are present over here, suppose there are several elements present over here, over here, etc. So we will get them placed in the contiguous memory locations in the physical system, in the physical memory, as like this. Suppose there is an element over here, there is an element over here, there is an element over here, and so on and so forth. So this is the row major representation, the figure of the row major representation, and there are some nitty-gritties into it. There are some technical parameters associated with it, which we will try to use in order to find some data values in case of some mathematical problems which are given pertaining to this entire row major representation. So for this, we will give you some basic concepts in order to handle those sums which come from this topic. So now the address of how to determine the address of an element Aij which is found in this two-dimensional array, that can be given by a formulation. I will just write down the formula and explain it to what are the parameters involved in the formula, what are the different terms used in the formula, and explain it to one by one. And now we will see the address. I will write the address of Aij, that is any element having the subscript of row, having the index of row as I and having the index of the column as j. The address will be determined by a formula which is like this: B plus, I will give you what is B, what is other parameters, I will just explain it to you. Let me write the formula first: B plus W, then a third bracket, then N, then I minus L1 plus J minus L2, then third bracket. So this is the formula of finding the address of the Aij element of a two-dimensional array. So what are these? What are these things? B is nothing but the base address. So B is the base address and N is the number of columns. B is the base address, N is the number of columns. I will write them one by one. So let me write them one by one. B is the base address of the array, where B is the base address of the array, and N is the number of columns, and L1 and L2. I have written over here L1, L2. So what are these L1 and L2? L1 and L2 are the lower bounds of the row and column respectively. L1 and L2 are the lower bounds of the row and column respectively, and there are other parameters as well which is quite similar to this concept L1 and L2, that is U1 and U2. U1 and U2 are the upper bounds of the row and column respectively. So U1 and U2 are the upper bounds of the row and column respectively. And how to find this number of columns? There is a formula into it also, how to find the number of columns in this sort of representation. That is, N is the number of columns which should be found out by the formula. I will write down the formula over here in order to find out the value of N. That is, N is U2 minus L2 plus 1. So this is the formula of N, that is the number of columns which we will use in this formula. N is nothing but U2 minus L2 plus 1. That is the upper bound of the column minus the lower bound of the column, and they will be different. They will have a subtraction between them. We will follow a subtraction between them and then add 1 to the result and find out the value of N, which is to be put in this formula as the number of columns. And this will help us to calculate some values in the mathematical formulation. So let me just write an example sum, a mathematical sum, which will help us to where we will use this formula, and this formula to determine some values, to determine some results from that mathematical problem. So let's write the mathematical problem and find the answer to it. So suppose we have written a problem over here. A mathematical sum has been given, a sum has been given here, which is like this: a two-dimensional array, a 2D array means a two-dimensional array defined as, the name of the array is small a. It is defined in this method. The index range of the rows and the index range of the column is given. The index range of the row starts from 4 and ends at 7. Index range of the column starts from -1 and ends at 3. So this means that is the column, the row index starts from 4 and ends at 7. This means the column index starts from -1 and ends at 3. So this is the definition of the array. The bound, the lower bound, upper bound, everything is given in this representation. Requires 2 bytes of storage space per element, that is one element of the array will occupy 2 bytes of memory. That is, you can easily understand what is that type of element, what is the data type of that element. That is 2 bytes means an integer data type. Any element of integer data type can occupy 2 bytes in memory. So the space, the storage space occupied by one element of the array is 2 bytes, means we are dealing with integer elements and nothing other than integers. If it would have been 4 bytes, or it would have been a float value, if it would have been 8 bytes, it would have been a double value, and so on. So we are dealing with the integer for the sake of simplicity. Calculate the address of the element. From this we have to calculate the address of the element at a particular location of the two-dimensional array where the index is 6 and 2, that is A62, the element at the 6th row, that is the row number 6 and the column number 2, that cell's address is to be found out given the base address of the array to be 100. So we will now apply the formula which has been cited above. So I will write for the formula once again in this sum, in the solution of the sum. That is, we will find the address of Aij like this: Aij to be b plus w n into I minus L1 plus j minus L2. So this is the formula of determining the address of the aijth elements, that is b plus w into n into I minus L1 plus j minus L2. So in order to find out this, what is this w? I've forgotten to mention the w parameter in the previous step. So this w is nothing but the number of bytes which is occupied by the one element of the two-dimensional array. Like this, in this sum, the value of w will be 2 bytes. That is, for integers this w will be 2, for float this w will be 4, for double this w will be 8, for character value this w will be 1, and so on. So w is nothing but the number of bytes occupied per element in this array which is under consideration. So we will try to find out this n, that is n has a formula we have cited above, that is n is equal to nothing but n is equal to u2 minus L2 plus 1. So n should be determined before u2 minus L2 plus 1 I have written above. u2 is nothing but the upper bounds of the rows, and L2 is the upper bound of the column. So these things we have to take into consideration. So there is u1 and u2, the upper bounds of the rows and columns. So this is the upper bound we have written before. u1 is the upper bound of, let me just recollect, upper bound of row, u2 is the upper bound of column, L1 is the lower bound of row, L2 is the lower bound of column. So what is this u2? u2 is the upper bound of column, and what is this L2? Lower bound of the column. The difference between these two will be added by 1 to find out the result of the n. So what is U2 over here? Let me see. This array is named small a, has this sort of dimensions. The upper bound of the column is nothing but 3. Upper bound of the column is 3. So U2 will be 3. The lower bound of the column, is -1. Lower bound of the column is -1. So now this n will be determined in this manner, that is U2 minus L2, that is 3 minus L2 means -1 plus 1, that is 3 minus 1 means 3 plus 1 is equal to 5. So we will get this as 5. So n will be 5. Now we will try to find the base address, try to find the address of the Aij element. That is Aij in our case is A62. So address of A62 will be B. B means the base address, which is given as 100 because it is in the sum, it is given as 100 as the input value. 100 plus W is equal to what? 2 bytes. Now this square bracket begins and the number of columns is 5. We have determined the column number of columns 5. This is I means this value, this is I and this is J. That is I is equal to nothing but 6 minus L1. L1 means lower bound of row. What is the lower bound of row? Lower bound of row is 4. Then plus J minus L2. J means this one 2. And what is this L2? L2 is nothing but the lower bound of the column. It is the lower bound of the column. Lower bound of the column is -1. Lower bound of the column is -1. So it gives a value of like this: 100 plus 2 into 5, 6 minus 4 plus 2 plus 1, like this. So it will give a result of 100 plus 2, 6 minus 4, 5 bracket 2 plus 3. Suppose this is the answer: 100 plus 2, 5 into 2 means 10 plus 3, that is 13. So 13 into 2 means 26 plus 100 is equal to 126. So 126 will be the address of the element at 62 memory location, that is A62. Address of the element A62 will be nothing but 126 if the base address of the 2D array is 100. So this is the way in which we try to find out the solutions of this sort of problems by using the concept of the row major representation. So friends, if you have any doubts and queries pertaining to this entire explanation, you can well post your queries and doubts into the comment section below so that I can address them. Thanks for watching this video.